Yeah.
I have two new buttons. Okay, good morning, everybody. My name is TK, and I work for Kulicke and Soffa for the Operation Engineering Department. So today I'm going to share with you our digital transformation journey that we took a couple of years ago, and how do we transform ourselves from a very primitive systems to today, I believe we have a system that allows us to compete effectively in the semiconductor space. So without further ado, let me start. So today our agenda is going to cover a few key points. I'm going to introduce a short introduction of Kulicke and Soffa, who we are, what's our missions. We're going to talk about a problem statement, the challenges we face in manufacturing operations. Like any engineer, you always start with a problem statement. And we're going to bring out 3 case studies. This case study will allow us to give you a brief introduction and understanding how do we transform ourselves from where we were and to where we are today. And the case study 3 will take us to the next lap, where we want to go. And then I hope to end this presentation with or sharing with a key lesson learned and what do we do and how do we do during the journey. Okay, so let me begin. A brief introduction of Kulicke and Soffa. So K&S provide a range of solutions to the assembly processes for the semiconductor back end of the semiconductor value chain. So we are founded by 2 engineers, our founder Fred Kulicke and Al Soffa in 1951 in Philadelphia in the States. So in 1971 we were listed in the NASDAQ with the code of KLIC. Currently K&S have about 2,500 employees scattered all around the world. And 80% of our revenue are concentrated in Asia or derived from Asia. Since 2010, our headquarters is in Singapore, in Serangoon North. So this slide shows you our global footprint. So we have 5 manufacturing sites scattered between Europe and Asia. We have 8 R&D sites from US, Europe, and also Asia, and 18 offices that serve our customers all over the world. So our solutions, the range of solutions that we provide for the assembly process in the semiconductor value chain, including ball bonder, wedge bonder, advanced packaging, die bonder, and SMT. So these are the equipment that we make with all our manufacturing site, and also consumables, for example, capillaries and bond tools. So I'm gonna start this sharing session with a definition of the challenges we face in manufacturing. And I'm sure some of you or most of you will face similar challenges in the past and maybe in the process of transformation. Let me begin with this journey. So this chart in front of you, I don't think will be very unfamiliar. So some of you has been running operations or part of operational engineering. You will know that once upon a time, a lot of data are being scattered all around the company or the manufacturing line or various processes. In the past, our decision-making process were based on very fragmented data because of the data are all scattered and not well linked. So in order to connect between the cause and effect, it sometimes takes a long time, and the data presented to us may be only partially correct and not factual. So a lot of time we're dealing with a lot of data, and engineers and managers spending a lot of time trying to collect the data, find out what is it. And most of the time, the data are actually not clean or a lot of error in there. So this is the statement that we started off when we're solving our challenges, solving our crises. So just a summary of the key challenges we face in the past. Usually data are recorded into forms, key into database, manually entered into the system. They are very error prone. It's a lot of error will be injected in during the process. Data are not systematically collected into our servers, nor the servers sometimes our database are connected together. And worst of all, the data are not structured. So it makes linking the problem and the root cause very, very challenging. And because of all this above, the decision-making process were based on very limited data. And collaboration between various teams, individuals, and engineers are very challenging because one of the major problems we see is that people don't see the same set of data. So when you don't see the same set data, you draw different conclusions. And that leads to a lot of discussions, argument, conflicts. And this is the challenge we also faced in the past. especially true in the current COVID environment where a lot of people is working from home. So if we do not have a common platform where everybody can see the same set of data, this is a very, very challenging environment. Time consuming. It takes a lot of time and effort to collect data. This is especially true during crisis situation when everybody's under stress and decision making has to be fast. So it takes a long time to collect data and make the data relevant for the decision making. And worst of all the above is also resulted in a lot of the paper reports being generated. It's a very environment unfriendly and resulted in a lot of wastages of paper consumption. So this is the problem statement we start off during the transformation. So we started with a simple framework that we took from McKinsey and Company. This framework is readily available. If you go and Google and search it, and on the link below, you can see it. So we asked ourselves, where were we once upon a time? And based on a few things, what are the indications from the data analytics infrastructure? Where were we? And then this framework allowed us to construct a very simple roadmap between the competitive advantage that we want to be and the kind of effort that we have invested in our systems. So we see ourselves long time ago as below 1, meaning that we do not have all the system in place to allow us to effectively benefit from this transformation. So we know where we were, and this is where we set a roadmap to move ahead. So I'm going to start with 3 case studies. We're going to have 3 case studies. I'm going to start with the first case study, talking about manufacturing operation, analytics, and decision making. So our basic belief is that the way we collect the data, the way we analyze data, and the way you use data have a huge impact on individual and organization behavior. So the word is behavior. And we believe this behavior will then influence the way the team and individual solve problems. And as a result of that, we can improve our efficiency in the business performance. So this is our belief, and we will start with this belief. So how do we do it? The first step that we do is to use the very traditional tested tools called Lean Six Sigma. Lean Six Sigma allows us to give us a tool called value stream mapping, a VSM. We use this VSM to methodically and painstakingly go through our business process and identify what is needed and what is waste. And based on that, we came out with this simple chart in front of you. So from the original state of paper reports and all the not correlated reports, we ask ourselves, what do we need to stop? So you can see from the chart, the first thing is stop collecting data that's not useful to us, that does not help you to make decisions. Then we ask ourselves, what do we need to do next to be where we are? So the second point we see is that we start to digitize our data, we automate our processes, we clean the data, and we locate all the database into a centralized database where we can then manage. Then from there onwards, we start to construct dashboards for decision making. So this is the simple flow that how we go about transforming ourselves from point A to point B. So I'm going to go into further detail with the next few slides. So the first question we have asked ourselves during that time is, how do you capture the data? So right in front of you is an illustration of one means of capturing the data. This capturing the data is from the supplier. So this situation is not unique to only KNS, I think unique to everybody. So when you have supplier all over the place, you want to collect data. Data could be test data, could be quality data, data could be related to the technical aspect of the information. So what we do is that we work closely with our supplier, allow them to pipe the data to KNS. And when this data come in a structured form, the way we want it, we then pipe into our server. So first tranche of data is coming from supplier using the synergy, using this diagram above. So our supplier could be from China, could be from US, could be from Malaysia, could be from India. So that allows us to really look into the data stream and then figure out what are the challenges we'll face. Second, data from the manufacturing floor. So we are very, very lucky to have our own competent engineers to develop solutions. So our solutions that we develop is very simple, based on tablet computer. So a typical technician would, instead of using papers and clipboards to write down and look at work instructions and so on, our tablets computers is able to provide the work instructions, the work order to the technician needed to run on a particular machine. He will upload from the cloud on the server, all the instructions. And then the technician will then able to communicate with the machine that is manufacturing at the moment. So information related to the work instruction, work order, or any parameters are being streamed from the iPad or the tablet computer into the machines. And then it will able to trigger a series of automatic testings or manufacturing process. The machine would perform its function, and as a result of that, there will be information coming from machine back to the tablet computer into a cloud. And those data that are captured are structured, are cleaned before they are sent into a server. Likewise, for all our assembly machine, whether it's fully automated robotic machines or partially semi-automated machine, they generate data about the parameters, about the performance, and all these data are captured by the systems and piped into a server. So how does it look when we put everything together? So in this chart, you can see that we have 4 sets of data. As I mentioned earlier, the first set of data is coming from our manufacturing execution system at the top, from the technician's iPad. They are captured into our servers and then go into a central database. The second set of data is coming from the automated machines, semi-automated machines. From them, they go into our server. The third set of information is coming from our ERP system. Our current ERP system is Oracle, so there are a lot of information related to the BOM structure, information related to serial numbers are captured by the Oracle and go into the central database. And the last set of data is actually from a supplier all over the world, right? From China, from India, from US, and also from Malaysia. So they are piped into KNS and go into the central database. And then what do we do with this data? We start to construct dashboard based on a KPI that we believe we need to do. And the dashboard is shown in the right side of the chart. I can see it could be yield, it could be productivity, it could be quality, depending on the needs of your applications. So data visualization is the key that we use to make this available. And once this is in place, the next step that we're going to do is about the process that the line manager use to transform those data into actions. So typically, a manager will have his meeting with his team members every week. In our case, it's always a Monday. So he will see all the various different dashboards. And one of the dashboard is right in front of you as an example. So what you will see visually is very simple. You have KPIs structured there, divided into week, month, and quarter. The KPI could be quality, could be anything that you wishes to track. So in this case, when the managers, together with his team of engineers, open up the dashboard, he will see some red colors indicating that something is not meeting the targets. So we have a very clear set targets, and the red bar there shows that something is wrong. So in the good old days, people were running all around, waiting for hours, for days, for weeks to get about, so what actually happens to the red bar. In today, our context, all the managers and engineers to do is to click on the red bar, and it will trigger a certain drill down processes. The drill down processes is shown, example is on the next slide, as you can see on slide 17. So what happens is that our visualization system using, in this case, there's a Tableau visualizing software that we use, allows the manager to have a very clear-cut overview of what's going on with the particular red bar. In this case, as an illustration, we have process A to process I, and particularly process B have the highest amount of rejects. So with this drill down, the managers together with engineers and say that I know that process B is the one that creates the most amount of reject. If I put my precious resource to solve, I will solve process B first, very clearly. And then if you continue to drill down, he will know, or he or she will know that under process B, what are the symptoms, what are the bots, who manufactured it, what are the serial number, at what time frame. And then he or she can deploy the resources, the precious resources to solve this problem first, and then work to the next problem, to the next problem. You do not want to, at this moment in time, to put your resources in the least severe problem. So we work with this method, you know that you are able to get the problem solved efficiently. So at the end of the quarter, we will have our system generated all the problems that generated in the line. And this is what we shown in front of you. We call it the waterfall chart. The managers together with the engineer can set goal for the next quarter by identifying the top 10 failures. Once you identify the top 10 failures, you can allocate resources, create mission statements for the teams or individuals for that particular quarters, and then measure them the effectiveness. If everybody does his job well and very clearly delivers, at the end of the next quarter, you will be able to solve the top 10 failures. Once you solve these top 10 failures or challenges or what you said, you're able to meet your goal. So using data analytics systems that we have employed, we're able to clearly deploy resources, able to communicate clearly on a statement, and able to collaborate better. And that motivates the team further. So the next step that we do to upgrade our system is to move into cloud computing. So in the past, we put all our system in our server. Right now, we put all our data into cloud. And cloud, when you put our information onto cloud, we call it data warehousing because we do transformation, we do a lot of data cleansing on the cloud. And what does it bring us is added capability. We then now move on to data monitoring. So imagine that suppliers or in-house manufacturing processes, we collect a lot of data. And now with the cloud computing, it will allow us to monitor the data real time. Let me explain further what I mean. So take an example of the chart right in front of you. This could be a representation of one of the processes in the manufacturing floor. We have many, many processes in manufacturing. This is just one of them. The dots you can see on the blue dots or towards the top left corner of the chart, you can see these are the data coming from the manufacturing floor. It could be a dimension, it could be electrical information, or it could be anything that we collect systematically. And then what we do is we write algorithm. The algorithm you can see is on the red box here. And algorithm, simple algorithm could be SPC algorithm, upper limit, lower limit, 7-point out, then you signal, or whatever algorithm that we can develop. So we develop a series algorithm based on SPC rules and some other algorithm based on trends that we develop internally. We plant this algorithm into these platforms or visualization platform, allow our engineer to identify where are the anomalies that generated during the manufacturing process. And when the anomaly are generated, the email sent to the correspondent engineers to take the corresponding actions. So these are the ways that we do it remotely. Even during this crisis, when our engineers are working from home, they are able to log into the cloud system, look at which process have a problem, identify the serial number, and call the technician on the line to remotely manage and solve the problem. So this is give us added advantage to really flag out issues before the issue get too big and snowball. So this is one way when we move to cloud, we're able to do this remotely with our system. So this is a same pictures, but we zoom in and can see that when the data are coming in the visualization software, data are look scattered all around. But once you start putting filters and algorithm, you are able to identify certain anomalies that you want to solve it before it's actually snowballed down. And then all these are traced by serial number of the parts that you manufactured, so it gives you a lot of traceability. Okay, I just completed the manufacturing process. The next case studies I'm going to go into is how do we manage our supply chain? How do we manage the performance and decision making related to supplier management? This is case study number 2. So before I begin to go into details, I just give you a glimpse of how do we manage our supplier. So we manage our supply in 4 key steps. We start with supplier assessment. We do a SWOT analysis and risk assessment to see whether suppliers are suitable. We engage them, we qualify the parts, and then yearly or quarterly, we have a performance review and allow us to review the performance and how they're doing and whether we decide whether to continue to do business with this supplier or we exit them. So this is our process. So we use several tools developed in-house. In this case, and slide 24 right in front of you are the tools that we develop, simple tools that we develop. So a typical buyer could be in buyers or supply chain personnel could be at home in Singapore or in China or in US, log in and see the system, right? He's able to do risk assessment of a particular supplier by keying in the data entry here. It could be simple scoring, like for example, how is the cost competitiveness, the quality system audit outcome. As the buyer or the SQE key in the information, the score will start to tally up because we have an algorithm behind the scene to take those input and convert to a score. Qualitatively, the buyer or the SQE can input information related to the swap, the strength, the weakness into this, and also convert the score. At the end of this process, what we have is a report card related to that particular risk of a supplier. And we can program any algorithm you want to allow you to see and score. In this case, the supplier score a 3.3 with a medium risk with a certain capability that we identify as a risk. And then we can continue to engage them and improve them. So with this system in place, we're able to use data to the fullest capability and collaborate around the world in order to do supplier risk analysis. Likewise, at the end of the quarter or end of the year, we can do a supplier scorecard using similar system, but the scoring system, of course, according to the needs, for example, performance or delivery, quality, cost reduction, opportunity, and so on. And then we can also, at point number 3, rank all the suppliers with the same community side by side. You can see where are the strengths, where are the weaknesses, which is the supplier we want to use, which is the supplier we want to exit. And then we can also go detailed drill down to a particular supplier in understanding the trend of a particular items. For example, commercial, delivery, quality, are they flat or they upwards or they are declining? And then we can have very good constructive discussion with supplier in this engagement. All this with the use of data and data analytics. Similar system that we deploy in the manufacturing floor, we also deploy to our supplier. Imagine a situation where you are a supplier residing in China, and this opportunity allows us to look into the data that are generated while they're producing the part, and we apply the same algorithm onto those data they collected and to look for trend. And in this case, it's even more pressing. Imagine that you identified challenges or problem or quality issue with the parts before the supplier put those parts onto a boat and ship to Singapore. In this case, it's about a 2-week lead time. And you can prevent this problem from happening while the supplier is manufacturing a part. These powerful tools allow us to stop all issues before it exits from the supplier into KNS. It saves us time, it saves us heartburn, and really improve our quality and productivity. So this is some of the data tools that we apply into our manufacturing processes to help us be more efficient. So case study 3, after talking about all these things that we developed over the last few years and using it to improve our efficiency, productivity, you may ask, what's next for KNS? What's next for your team? So our answer is machine learning. As you can see, with the current data structure, what we are moving towards is predictive analytics. Everything that we've seen so far is all about data, data, data. Data is the new oil for the next revolution. So one of the best things we can do is to use predictive learning, meaning we are able to use machine learning to capture the data. So whenever we collect data, we will capture a set of data and turn it to 50% that was used for training the system and 50% for evaluating systems. And by doing that, we're able to teach the machine, teach the process or the machine learning algorithm to learn about a particular process. That process could be manufacturing, that process could be quality checks or whatever you call for. And then what is the benefit of predictive analytics? The benefit is very simple. If you can prevent something from happening while you're manufacturing based on certain learning profile, you're able to prevent problem before it even happens. Or put it another way, you can even understand what are the causal relationship between what was a defect that you detected and with what are the possible root cause and where are they, and with a high degree of confidence that that is a root cause. So with machine learning, it gave us this added capability to predict into the future by learning from a process. So to do that, we have to transform our talent, our in-house talent, our engineers, not only to appreciate data, but to learn programming language that allow us to do machine learning. So this is important because we are now transforming our subject matter expert, our engineers that know the process with the new skills called machine learning skill through the programming language. And we empower them to learn, model the process, and then predict the process. We don't do this alone ourselves. Over the last few years, we partner with National University of Singapore, NUS, to transform and to help us to ramp up this capability of learning, of machine learning. And then we have been partnering well, and we have benefited a lot from this partnership, working with them closely towards transforming our digital systems from a very passive systems to a machine learning that focus on learning and improving the system over time. So we have to thank NUS a lot in this transformation, and we are moving towards that direction. We are not there yet. We are still in a process of learning, fine-tuning our system. We hope one day we can allow our entire enterprise to have a machine learning capability to predict before things fall apart. So up to this point, let me do a summary of where we are from a perspective of our digital transformation journey. As I mentioned to you, we believe our starting point was one couple of years ago. Today and tomorrow, we believe we are now in the range of 9 anomaly detection going to predict analytics. And we hope in the next 2 years, we can go to enterprise networks able to predict the capability of our process from the entire enterprise perspective. Okay, this is where we are about 9 to 10. So let me sum up my sharing with you with some key lesson learned. So important thing we learned throughout the journey is, firstly, as an engineers and engineering operations, we need to clearly define our statement. What problem do we want to solve? And how do we transform those problem statements into KPIs that we can measure? Because you cannot improve something when you cannot measure those. Second, leverage on tools that is very, very well established. Using our SME to use Lean Six Sigma to use value stream mapping to really map out the entire process. As you go through this mapping journey, you will learn a lot more about process, what needs to be done, what needs to be scrapped, or what needs to be improved. And we benefit from this Lean Six Sigma value stream mapping process to improve our digital system. Third point is very important, is about bottom up and top down. So digital transformation is not about the top telling the people in the ground level, do whatever you need to do, or do this or do that. It's about setting a very clear goal. What do we want to do to be successful? At the same time, we rely a lot on the ground level engineers that really understand the process, the SME that deal with the problem day in, day out. What we're trying to do with this process of transformation is to empower them, is to provide them with sets of skill and tools to allow them to do the job better and be more productive. As I said, when this top and bottom collide together or connect together, we have a better system. The behavior will change, the collaboration will change, and the whole enterprise will be more efficient. A fourth is basically a systems to systematically collect the data. There's so much data abundant, especially in a manufacturing system. So really understanding how do you systematically collect those data and put them together is very, very important. Without those data collection plan, you will not have a good system. Finally, once you collect the data, you need to transform the data in something that's usable, that can be solved the problem. So we went through a whole process of really transforming the data to make it available for decision making. So with that, I conclude my presentation, my sharing, and I hope it's useful in your line of work, and we can talk more from here.
Thank you, TK.